record as well. All right. So good morning, everybody. Thank you for joining our webinar from Save Red Rock about the Make It Rain campaign. My name is Michelle. I'm Director of Communications for Save Red Rock, and I'm going to be introducing today's panelists and helping all of you in the audience get your questions answered about cloud seeding. So first, I'd like to introduce our guest of honor and our presenter, Frank McDonough. He is an atmospheric scientist and program manager of Desert Research Institute's cloud seeding efforts. So he really is the guy on the ground executing many of these campaigns throughout the country. So we're very excited to have him. Welcome, Frank. Thank you.
Thank you.
And Frank has a very informative presentation that he's going to share with you all about how cloud seeding works. That'll be the main purpose of this webinar. We also have Pauline Van Betten here. Hi, Pauline. Pauline is land and water specialist for Save Red Rock, and she is one of the key partners in creating this partnership. So we're so excited to have her perspective. And of course, the wonderful Heather Fisher, president of Save Red Rock, also here to lend some information about our donation drive and how the community can get involved. So thank you, panelists.
Thank you.
Before we get to Frank's presentation, Pauline, I'd like to kick it to you for a second. Could you just frame this project up for us? Can you tell us, what is the Make It Rain campaign and why is it important?
Thank you, Michelle. Well, we're all here today because we love Red Rock Canyon. We love walking in the wildflowers. We love biking in the Joshua trees. We like climbing in the canyons, and it's not doing so well. The Joshua trees are really dying and it's really in dire condition. But we believe we have a solution. And when we met Desert Research Institute and learned about their cloud seeding techniques, we really feel like this is the boost that the canyon needs. Right now, the Cottonwood Springs Water Stewards were formed 2 years ago to address drought conditions, because Save Red Rock really felt this is the main problem for Red Rock right now are the drought conditions. The Cottonwood Springs Water Stewards focus on 2 primary springs that provide water and life to 80% of the wildlife in Red Rock Canyon. And 15 years ago, the lower Cottonwood Springs was a 4-foot deep swimming hole. The upper Cottonwood Springs was full of reeds and frogs and birds and all kinds of water plants. And they're both bone dry, and they've been bone dry for years. And the animals are moving into Las Vegas, desperately looking for water, and we need to help. And again, everyone that's here has the ability to help with our fundraising. Our partnership was formed to help bring funds to the time-tested solution that Desert Research has for cloud seeding. Frank's going to give us some very extensive information and answer all of your questions. And once again, thank you all for coming.
Thank you, Pauline. And that's a great segue to Heather before, again, we just get to Frank's presentation. Red Rock is currently raising funds to support this environmental action, and I hear that you have some news and some updates to share about that.
Yeah, it's very exciting. We've only been up for about 7 days. We started on September 1st, this fundraiser. It's called Make It Rain campaign. And it's really exciting because eventually we want the government to take over. But for that to happen, they need to see public support and they need to have local public matching. And so we need to raise $150,000. And in the first 7 days, we're really excited to announce that we have raised $29,104.47. And even that 47 cents matters because it means somebody cares about Red Rock and they care about this drought and they have hope in the future. That's what I love about this program. It's not just, wow, we're going to die. It's figuring out a new solution, and it's coming together as a public to make it happen and to show the government that this is worth it. The public is behind you, and we have faith in it, and you should too.
Yeah, so to just clarify that point, what we're aiming to do is that Save Red Rock doesn't want to fund this in perpetuity. Save Red Rock fund this campaign, make it a success, and then go to the state legislature and hope that they provide funding in perpetuity for the drought that's obviously not leaving us anytime soon.
Yes.
Amazing. So thank you, Heather. Thank you, Pauline. We have quite a few attendees I know waiting to hear. So I'm going to kick it to you, Frank.
Okay.
I know you have a presentation for us and you're going to tell us all about how this works. And then just so you all know, attendees, if you have questions while Frank is presenting, you can submit those in the Q&A portion of this. And we will kind of point out when he's addressing your questions. And anything that was sort of unanswered, we'll make selections of your questions at the end for a formal Q&A session with Frank, okay? All right.
All right, thank you. Okay, so I'm going to talk mostly about cloud seeding in general, but I'll go through a little bit of work we've been doing in the Spring Mountains over the last 3 or 4 years, and yeah, and then I'll go through. Probably some of it might be a little technical. Hopefully, it's not too technical. And if you have any questions, save them for the end, and I'll look forward to answering all of your questions. Okay, so here's a quick shot of the Spring Mountains from the west side during the big winter. I think it was 2018, and this was a humongous winter. And there's a great shot of Mount Charleston with a big, nice bowl waiting to be snowboarded. So the project overview. So like Pauline said, the continuing long-term drought across the Southwest does include Red Rock Canyon Park. And the impact of this drought is decreasing the water resources in the park, and it's negatively impacting the park resources. And in order to try to increase these water resources, we are proposing a cloud seeding program. And the goal, obviously, is to increase precipitation across Red Rock Canyon and also the greater Spring Mountain area. So there's 2 primary seasons or precipitation periods that add rain or snow into the Spring Mountains in the Red Rock Canyon area. And one of them is winter precipitation. They're winter storms. They usually move off the Pacific. They have widespread precipitation where they, precipitate over the entire mountain range. And studies of some of this water that ends up in the groundwater recharge areas in the spring suggest that about 70% of the total recharge in the Spring Mountains is coming from winter storms. And then the other precipitation producer is the southwest monsoon, which should be ending in the next couple week or two. And that's when thunderstorms and moisture gets pumped primarily off the Gulf of Mexico and gets pumped across the Southwest and up into southern Nevada. And that usually on average is about 30% of the total precipitation that is part of that recharges the area. And the thing with the monsoon is that it's more localized. So you might have a big storm in one area and nothing in other areas. So it doesn't cover the whole area, but you can actually get quite a bit of rain in one spot during any particular season. And so I'm going to primarily focus on winter storms for this discussion, but we can talk about the Southwest monsoon cloud seeding at a later date. So to understand cloud seeding, you got to understand what are clouds. And clouds are, like up there in the sky, they're like big puffy things and they look like dinosaurs or boats or whatever, but they're actually collections of liquid water drops and or ice crystals, and they're within saturated layers of the atmosphere. By saturated, I mean the air can't hold any more water vapor, so it has to convert that water vapor over into cloud particles. And so here's a shot of some clouds over the central Nevada, and then these are some pictures of some particles inside of clouds that was taken by a research aircraft. And so here can you guys see my mouse by any chance or no? You can. Okay, cool. So this is a dendrite ice crystal. These are some capped columns of also an ice crystal. These are water drops here. And so we have the ability to fly through clouds and actually see what's in the clouds. We can count how many of them there are and do all kinds of cool stuff. But anyway, so a cloud is a collection of either liquid water drops or ice crystals. So how do liquid water clouds form? Well, moist air is lifted, it cools, and as it cools, the humidity increases. And as the humidity approaches 100%, the water vapor needs to start to come out of the cloud. But it can't just come out by itself. It needs to come out with the aid of some type of condensation nuclei. And these are usually things like sea salt, smoke, dust, all kinds of things serve as a aerosol particle that allows cloud droplets to form. But without these aerosols in the atmosphere, we wouldn't get any clouds. It would be blue sky every day and it would never rain. So these things are super important and they're highly variable as well. So here's an example of clear air here on the left, and you can see the water vapor molecules are these blue guys that look like Mickey Mouse ears, the H2O. And then this is a CCN, cloud condensation nuclei. And then as the humidity increases, the water drops form, but you see the water drops have to form around each some type of aerosol particle. So every drop is forming on some piece of aerosol in the atmosphere. And to form clouds, they can be liquid or solid. There's lots of sources for these things. There's natural sources such as volcanic smoke and sea salt, and there's all kinds of natural drop forming areas of salts. And then there's also man-made ones, like when you drive around in your car, especially in colder winter seasons, and the pollution gets trapped. All this stuff here is aerosol pollution in the atmosphere, and if that gets into clouds, which it will when the next storm comes through, then that'll affect how the cloud particles form and how effectively it's able to produce precipitation. So in contrast, how do ice clouds form? So these are a little bit more complicated. Same idea, moist air is lifted, it cools, the humidity increases. And if that air is cooler than about minus 40 degrees C, which is the same as minus 40 degrees F, then you can actually get the drop to freeze by itself. But if that cloud's warmer than that, it needs some type of dust particle to help it form an ice crystal. And those are called ice nuclei. And so basically, if you can form ice, but you need this special dust particle. And these dust particles don't really start to form ice in any significant way until the temperatures are cooler than about 5 degrees Fahrenheit. So in clouds warmer than 5 degrees Fahrenheit, you have a bunch of water drops, but that are below freezing. They're small, they don't precipitate, and they just sit there in the cloud. And so, yeah, so let's go. The next thing that's kind of interesting and maybe a little bit complex is that once an ice particle forms in a cloud with water drop, then that ice crystal is going to quickly start to grow at the expense of the water drops. And so there's two ways that ice crystal can grow. It can grow by the water drop, like here on the left, the water drop will start to evaporate and the water vapor will just move over and start to grow onto the ice crystal. And they call that deposition. And then the other way you can grow ice is by having the ice crystal actually crash into the water drops and they'll freeze onto the ice crystal. So this is a shot of a snowflake that fell through a cloud loaded with water drops and they all froze to the cloud. And here's another shot of a ice crystal that fell through a cloud with less water drops. You can see just a few of them here frozen on the edges, but nothing like this upper crystal. So they're the two ways that ice will grab onto the water and grow and eventually create precipitation. So these aerosol have lots of impacts on clouds. So the different types of aerosol populations that are in clouds affect how efficiently the cloud can produce precipitation. And this is sort of a rehash of what I just said, so I'll move on. So what is cloud seeding? So the goal of cloud seeding is we're going to purposefully introduce special ice forming dust into clouds with liquid water that's colder than about minus 23 degrees, or sorry, colder than 23 degrees Fahrenheit. and warmer than about 5 degrees Fahrenheit. So we have this window where we're trying to introduce these ice forming dusts into the liquid water layers. These special ice forming dusts will then form embryonic ice crystals in those clouds, and then these newly formed baby ice crystals then will slurp up the water like I just showed, and they'll grow into precipitation sized snowflakes and then start to fall to the earth as increased precipitation. And then there's also increasing evidence that's suggesting that air pollution from human activities upstream of mountain ranges is reducing the ability of clouds to produce precipitation. So we have increasing pollution getting into these clouds. These clouds now are having a slower production of precipitation, and sometimes they're not producing precipitation at all. So we have a decreasing cloud efficiency from our own pollution, and that's why we're potentially seeing less precip from storms. So here's just an example of what cloud seeding would look like. So you start out, you have a real thick cloud these are full of water drops below freezing, real small, no precipitation's falling out. You introduce the ice crystal. The ice crystal then starts to grab onto the water drops, grow into precipitation sized particles, and you can end up with snow from something that wouldn't have snowed in the first place. So that's kind of the overview of cloud seeding. So how do you do this? There's several ways to do it. I'm going to show an example here of how to do it from a ground-based cloud seeding generator. So you do climatology studies and you understand how the winds move across certain areas that you're interested in doing cloud seeding in, and then you site the equipment. So here the generator would be sited right here, and the storm wind would be coming from left to right. The cloud seeding generator is going to release its silver iodide aerosols. They're going to go up into the cloud, participate, and this cloud will, by the weather forecast, will know that this has supercooled or sub-freezing water drops. Once the aerosols get in here, it'll create ice right here. This ice will grow and grow and grow and fall out over the mountains, and then on the downwind side of the mountains, the cloud evaporates. So without the cloud seeding, the air would go up and this would stay all small drops, and then we'd come down the other side and we wouldn't have any precipitation, or we would have minimal amounts of precipitation. So here's a couple of shots of how cloud seeding is released. So this is a ground-based cloud seeding generator. This one's in Colorado. And so the silver iodide or the ice nuclei are released from this area up here, and they get up into the clouds and they do their thing and try to create additional snowfall. Now, this can also be done by aircraft. Here's an example of an aircraft with what we call flare rack. And the way this works is the aircraft takes off, flies into the clouds, upwind of the area it wants to seed, and then these flares are burned one at a time, and they release the aerosols that create the ice crystal. It's the same exact stuff that's coming out of the ground-based generator. It's just being put into the clouds from the air. And then there's other methods to do, and I'm not going to get into that today, but there are some other methods to cloud seed that have certain requirements, and this particular liquid propane ones it does work, but it needs to be done in really high altitude locations where all the processes remain in cloud. I should mention that this silver iodide, or this aerosol that we release from this generator, doesn't have to be released directly into the cloud. It has to go up into the cloud. So it can go up before it gets into the cloud. It's not important to release it directly into the cloud, where this particular method, you have to release directly into the cloud. So you're obviously probably thinking, well, what is this silver iodide stuff? Well, silver iodide is a rock, basically. It's a naturally occurring rock that gets mined. It's found around different parts of the world. And here's a picture of what it looks like. And it's naturally occurring. It's an inorganic molecule. And the reason it works well as a ice crystal forming nuclei is because it has a molecular structure that's real similar to liquid water ice. So basically what happens is the water vapor's moving around real fast, and it's trying to adhere to something to try to form an ice crystal. but it has difficulty. But when it finds something that has a similar molecular structure, that allows water vapor to start to attach to it, and then you can eventually form the ice crystal. And like I said, this aerosol is really similar to ice, so it forms it at a warmer temperature than other types of aerosols, which need colder temperatures before they'll allow ice to form. And then I'd also like to point out that this is a solid. It's released as a solid, it remains as a solid the entire time, and it falls out as a solid. So some people, I get a lot of people letting me know that they have concerns about silver, and there's silver ions are relatively safe, but there's some literature studies that suggest that silver ions can have somewhat of a detrimental effect. Now, what we're releasing is called silver iodide. Silver iodide is an uncharged molecule, and it's insoluble in water, so it stays silver iodide at all times. It never turns into a silver ion, so it doesn't disassociate. It's not available to the biology, so it just stays as basically a piece of dirt, a dust particle on the ground. And silver ions are charged. That's why they have some negative impacts. And cloud seeding does not add any free silver to the environment. There's been a bunch of studies. I don't know if I'm going to go through this, but there's been, obviously this is studied all the time, this silver iodide's impacts on the environment. So I guess I'll go through it. So basically, since the 1980s, there's been more than 100 Sierra Nevada lakes and rivers have been studied to assess the potential issues regarding cloud seeding, and no detectable silver above the natural background has ever been found in the seeded target area water bodies, in the precipitation, or in the lake sediment samples, nor is there any evidence of silver accumulating even after 50 years of continuous seeding. So there's a project in the Sierra Nevada, the McCallamy River Project. It's a hydroelectric river, so that there's dams and they generate power for the Pacific Gas and Electric Company. And that area has been seeded since the 1970s, the early 70s. And even after 50 years, they compare the chemistry of lakes and sediments in the target area to ones in Yosemite, which has never been targeted, about 100 miles away, and there's no difference. They can't see any difference. So that gives a lot of confidence that there's no accumulation and there's no negative effects. And just a little more, so these high alpine lakes have no buffering capacity, so that makes them extremely susceptible to acidification. So if there was any problems, we would see it. And the studies are conducted to make sure that that's not happening. And no evidence has been found that that's happening, nor is any evidence in the theoretical sense suggest that it would happen. Here's another study that was done in Australia, and here's where these guys go. They were doing a cloud seeding project where the target area was a national park, and again, it was a hydroelectric project, and they spent $35 million on this project just to understand how it could be done. They had a lot of environmental hurdles to clear before they got approval, and they were able to get through all of them. And this is one of the studies from that project. And just the summary is they consider the risk, after looking at all the chemistry and all the observational data, they consider the risk of ecotoxical impacts to be negligibly small. So moving on, so that hopefully that wasn't too much. So there's three common questions that come up when you talk about a cloud seeding program. And the first one's obviously, does this work? Because it seems kind of crazy that you can just make it snow by doing something, by releasing dust in the atmosphere. Well, the answer is, yeah, it does work. And there's been some recent studies that are actually been pretty decent. One of them, like I just showed, for the Australia project, it's called the Snowy Precipitation Enhancement Project, and they had a lot of instruments out there. They had, like I said, they had a lot of money, and they were able to show a statistically significant 14% increase in snowfall for their project. And they used statistical measurements, precip gauges, and trace chemical evidence to show that the increase in snowfall was related indeed to cloud seeding. There's been other projects in the central Sierra Nevada. There's been a project by Southern California Edison, which isn't active at the moment, but they seeded there for 50, 60 years almost continuously. And so they collected a lot of data, and they were able to show approximately 4 to 5% increase in stream flow with 95% confidence. So that's statistically significant. And then there was also a project recently in Wyoming where they showed a 5 to 15% increase in snowfall. And they also used a lot of different methods, including modeling. And then there's physical validation studies. So we do this a lot. We'll go and set up collection sites and go out and try to catch snowflakes underneath the cloud seeding plumes and try to see if we can see increased precipitation rates and also different types of particles that would suggest that ice crystals are slurping up super cold or sub-freezing water. And over here is a good example of what we would expect to see if we're seeding. This is ice crystals buried inside here, and it's collected so many water drops that froze onto the ice crystal that it looks like a styrofoam ball. And I'm sure most of you've seen that if you get up in the mountains very often, especially in the spring mountains where it seems like they're there a lot of the most storms. So the next question is, are there safeguards built into cloud seeding? And the answer is yes, of course there are. So as I previously said, there's numerous environmental impact studies that show no negative impacts. And then there's also suspension criteria. So obviously we don't want to create so much snow that when it melts, it's going to come down the canyons, or so much rain that it's going to cause problems with flooding. So we're watching the weather real close. We're watching what's already been fallen and things like that. And we have suspension criteria built in, and this project will have that as well. We'll look at the weather and we'll look at how much precip's fallen, and if things look like they're going to cause some type of hazard or some type of problem, then we'll suspend the project. So the next question, which is one that most people think of too, is, well, if I make it snow in one spot, does that mean that another spot's not going to get snow? And the answer is no. It's unfortunately not a super easy answer, but I'm like easy to explain. But I'm going to take a crack at it here, and hopefully this makes sense. So we're going to start out. We start out with blue sky. All of the moisture is in the water vapor form. So right now everything's water vapor. There's no water, there's no clouds, nothing like that. So say a cloud forms. Well, now 20% of that water vapor has been converted into water drops or ice crystals, and the rest of it is still 80% is water vapor. Now say that cloud starts to precipitate and 6% of the total moisture comes out of the cloud and 14% of what was in the cloud originally. So we started out with the cloud with 20%, 6% fell out. So the cloud's still holding 14%, and then the air still holding 80% of the original water vapor. So if we cloud seeded that, we add 10% more precipitation. What we end up seeing is that we add 0.6% more moisture comes out of the total moisture comes out of the cloud. So now the cloud has 13.4% of the moisture because we improved its precipitation efficiency, and instead of 6% falling out, 6.6 fell out, and the 80% water vapors just goes along for the ride. And so once the cloud moves away and we were done, 99.4% of the original moisture minus the precipitation that would have fallen out anyway is moving downstream. So we haven't taken out hardly any because so much moisture goes past the area that never even turns into a cloud. So the amount of water that's taken out is negligibly small. And an example is, say the RH in a certain spot started out as 55%. The RH leaving the area would be 54.5%. So that long-winded thing is that the cloud seeding does not steal precipitation from downstream users. And there's been tons of studies on this, and they've never shown that any negative effect on precipitation downwind of a seeded area. So we've done a couple projects in the Spring Mountains over the last couple of years. We had a project that was targeting the west side of the Spring Mountains. This was, so I'll show some results from not this past winter, but the winter before last. And for this project, we had one generator. It was sited over on the Pahrump side of the mountains. And our climate studies have shown that south to southwest winds are the winds that deliver precipitation. And so anyway, we had a nice project. The analysis, so here's the set of rules that we wanted to use to decide whether or not we were going to cloud seed. So the first thing is we needed the cloud bases to be below mountaintop level. Number two, like I said, if the clouds have to have the sub-freezing water drops. If you don't have the sub-freezing water drops, that's like the fuel to create the additional snowfall. So the clouds have to have the sub-freezing water drops. And our experience down there shows that almost every storm has the sub-freezing water drops, almost the entire storm. So we have a weather station that we partner with the Lee Canyon ski area. It's sitting up on top of the ridge there. Here's a shot of it during a storm, so you can barely see. It's just a big fog bank, and that's what we want to see. So, and if you look real close, there's a bar here, and we can actually watch the sub-freezing water drops freeze onto this bar, which gives us a lot of confidence that we have the clouds we're looking for. And then we also have the temperatures and the wind directions up there as well. So that's pretty much like an exact measurement right inside the cloud. And so that's what we're looking for. We're looking for the sub-freezing water drops. And then we want the temperatures at 11,000 feet to be colder than 23 Fahrenheit. And then the winds for this particular project had to be from south-southeast through southwest, and that would eventually drive the seeding plume up into the mountains. So now let's take a quick look at the snowpack data. This is sort of a snapshot of how precipitation falls in the Spring Mountain areas. This is from the Lee Canyon, a site called Snowtel, which is a snow measuring site. And this one's, I think this one's about 8,600 feet. And so this is the total snowpack from 2008 through 2021. And so you can see that, and then the median is this red line. So you can see that in 2008, it was pretty close to a normal year. Then we had a couple of pretty good wet years, especially 2011. Then a bunch of crappy years below the average. And then 2017 was pretty good, got somewhat above that median line. And then 2018 was horrible, like one of the lowest years on record. And then the next winter was big, and next winter average. So, you can see that the way the seasons work, and most of these big years are associated with El Nino winters. So we see that for the most part, when the El Nino is present, there's a stronger southern storm track, and that tends to bring more storms into the area. So that's kind of what we've seen over the last decade or so in terms of precipitation. And then what we do is this is the zoomed in snowfall trace for 2020, 2021. Every time that this line is increasing, we're seeing a precipitation falling. And when this decreases, the snow's melting away. So here in like November, we got some snow early, and then it melted, and then we got some more snow. And then we had a bunch of more storms. And then by the late March, we hit the max snowfall, and then everything melted away by the first week of April. So that's kind of what we look at. Then we go through each one of these storms, and we look at how we did in terms of cloud seeding. So all these bars are places where we ran the cloud seeding generator. And so what we want to see is when we're running the cloud seeding generator, we want to see the precipitation increasing. And then sometimes when we see precipitation increasing, but we don't run the generator, we take a second look. It's okay, well, for this particular period, it was too warm. And over here, the wind direction wasn't good. So we weren't able to cloud seed because we wouldn't have been able to release aerosols from the generator and get them up into the mountains. But for the most part, you can see the equipment's placed really nicely. And we had a good project there. And then we go through a bunch of analysis and look at how we did. And here's the monthly seeding events. Here's how many hours we ran the generator. And then we run through a bunch of analysis, and we estimated that for this particular project, for that winter, we added about 3,300 acre feet. And an acre foot is enough water for 2 households here in Reno. So I'm not sure if it's, since you guys have been forced to pull out all your landscaping, I bet an acre, or the average Vegas house uses less than half an acre foot. But anyway, that's enough water here in Reno, at least, to supply all the water needs for a year for 6,700 households. So it's a bunch of water. And we estimated that the cost was about $10 per acre foot. So what we're talking about doing here is doing a similar project. We're going to focus though on the Red Rocks Canyon area, and then when the winds are right, we'll push the plume up into the higher portions of the Spring Mountains as well. So we're going to place a cloud seeding generator, maybe 2 of them. We're not sure. We're looking at a second site, so we're trying to find 2 sites. We have one site that's really good already lined up, and so we'll probably try to find a second site. And we know from the climatology that the wind directions are such that this spot will pick up the most favorable wind directions when low clouds are present. And we're going to try to increase the efficiency of clouds to form precipitation over the Spring Mountains. So the target areas are going to be where these red arrows are going. We know from our climate studies and also the years we've been doing this project that the storm winds are anywhere from south-southeast through south-southwest. We'd start seeding or start trying to look at the weather about November 15th. That would be when the storms are getting cold enough to do this. And we'd run through the entire winter. We look at this, every day would be a possible seeding day if the clouds are there. And then we'd probably end the winter project around May 1st. And obviously the goal is to increase the water resources. And I'll stop there and I'll take any questions.
Well, thank you for that, Frank. I'll give the attendees some time. It does seem that Tina has a question, so I'm gonna allow her to talk.
Good afternoon or morning, I'm sorry. So I'm curious, I've supported the fundraising effort, but I am interested in the likelihood or interest of Clark County in participating in this effort, and particularly because Justin Jones and Michael Knapp have been big supporters of our efforts to deal with any sustainability issues that we have here in the county. So this is a question for Save Red Rock and not our scientists from DRI.
Yeah, thank you, Tina. Pauline, did you want to address the sort of historic overview of the legislative support of cloud seeding in general and these environmental efforts?
Actually, I think Frank has a really good and clear historical account of his efforts with the legislation. So I'm going to kick it over to Frank.
Okay, well, so basically cloud seeding was discovered in the late 1940s, and the first cloud seeding program there was a bunch of research programs done in the 70s. And then I think it was 1976, there was a pretty bad drought in 76 and 77. So the state of Nevada funded an emergency project of cloud seeding program to try to mitigate the effects of this drought in the 70s. And that led to a program in the state that was funded originally in the 1980s. And that program actually existed from the 1980s through about 2009 or 10, when we had that big recession, and the state coffers obviously took a big hit, and the state wasn't able to fund the program after 2010. And so the weight of the funding the projects moved down to the local areas. And so what the certain areas were seeded, like the Ruby Mountains and the Tahoe area and the Carson River, Walker, and there may have been a small project a couple years in the Springs, I'm not sure, but that one wasn't a continuous project. And like I said, and then in 2010 the project ended, and it was renewed for 1 year in 2017 by the legislature, but it wasn't permanently renewed. And so it just, kind of can't win the competition for funding, which is obviously, when you go to these legislative sessions and you see all the diverse people that are looking for funding, it's a hard job. But I'd also like to mention that there is state funding in Utah, Colorado, Wyoming, and Idaho. All of those state governments support cloud seeding projects, and Nevada at the moment doesn't. But we're always talking to the folks in Carson City and seeing what we can do. But at the moment, there's no state funding for cloud seeding. So I don't have anything specific to say about Clark County. I don't know. I haven't ever talked to anybody in Clark County about funding cloud seeding.
We do know that we have support from Justin Jones and others, and our goal is, as part of our funding, and our goal is to lobby to get others involved. It would be a state program, not a federal program. So we're looking to our state elected officials.
Now, does that answer your question?
No.
What can we clarify?
First of all, the new Inflation Reduction Aid Act has a lot of federal funds available for state resource management, which our U.S. Senator Cortez Masto has pursued. So I'm wanting to know if your organization, in conjunction with Clark County, has applied for any of that funding that's available, particularly for water management and water resource management. So there's a source. Clark County also, because this resides within its jurisdiction, I wouldn't just rely on state resources. I think we can also maybe get some money from the county that they've received from the Recovery Act, as well as the IRA. So I appreciate Save Red Rock's efforts in pursuing state legislative support, which only meets biannually. Our county commission meets twice a month, every month. So I just think there's opportunities there. If it's a person don't have enough people to help pursue this, then let your membership and or people watching this know. Anyway, I'm going to shut up now. I just think that there's some more local resources now through some funding measures that I don't think we need to be waiting for the state legislature. That's all.
Yeah. Completely agree. And actually, Heather, did you have something to add to that as well in regards to the amount of outreach from funding that Save Red Rock's executing?
Yeah, thank you, Tina. Those are some really good sources. We'll have to get with you after this to talk about some of those grant sources you were talking about. We're also reaching out to the federal government, because even though the state would be funding it, the state needs a federal pool of money to get that from, because they probably won't take it from their general fund. And one such would be like the Drought Resiliency Fund. So we're talking to Susie Lee, and we're talking to Catherine Cortez Masto, and we're talking to the federal legislation that is currently over Red Rock, and we'll keep up with them to see who will be also after the election as well.
Thank you.
Thank you, Tina. You're muted.
Yes, there's some other questions in the chat that have to do with this issue, so I believe we've answered them. Are there any other questions you all can put in the Q&A chat? Otherwise, we'll conclude that portion of the webinar. So I'll just give you one more minute. Frank, was there anything else that you wanted to sort of add as a last minute the last minute summary of what you have or a takeaway that you really want to make sure this crowd hears at the very last stage of this webinar?
No, I mean, I just want to, applaud your efforts, because, like I said, I've hiked in Red Rock Canyon before, and it's awesome. And I the first time I visited Red Rock Canyon, I came to Vegas in the early 1990s. And I had no idea it was even existed, and I ended up taking, I thought maybe back in the day they'd had a bus, and I just took a bus out there and started climbing a canyon and climbing up one of the canyons. And it was a hot May day, and I ended up finding this incredible pool that tucked in some rocks, and I took a swim, and it cooled me off, and I was just sitting on the rock all cooled off and looking out at the beautiful landscape. And I was blown out, because like I said, I had no idea it was even there. And all of a sudden I'm in this incredible landscape and enjoying a nice cool swim in a great spot. So I'm looking forward to helping get some more water up there.
Yeah, we are too. Pauline, Heather, any last thoughts?
I like that. You enjoyed a nice cool swim in the water. We need that water. That's great. Yeah, no, I think this is great. I think we've been getting a lot of messages in and donations in, and we will also be rebroadcasting this in case more people have questions about how it works and where it works, and we just want to be able to show you that it's not just a pipe dream. This has been happening, and there are results, and it's just really exciting, and it doesn't hurt anybody else, because if the cloud doesn't rain here, it just dissipates. So it's all safe and good, and we're just excited to hopefully motivate future government funding.
And we do want to thank some of our big donors. I know some of our donors we've been thanking in the chat, so thank you all who have participated. We do have a larger sponsor donor that we want to thank. So Jeremy Burkhardt came in with $25,000 in the initial part of this campaign to donate. He's chairman of Origin Acoustics, so thank you, Jeremy. Heather, any other sort of donors or sponsors we should thank before we close out here?
I do. We have a really exciting match donor that will match your donations, actually double match your donations, and that is Tom Thomas from the Thomas and Matt, actually Tom and Leslie Thomas. So thank you very much, and he is banking on your faith in this project as well. So whatever you put in, we will double match it, or he will double match that for you. Thank you so much for that boost, because hopefully that will get more people coming in faster. Like Frank said, the faster we can get the funding, the more clouds we can hit, and the sooner we can mitigate this drought that we've been having for so long. And I also want to thank a few more raindrop donors. I didn't get a chance to post them all on here, so I'm going to thank Carrie Halkyard, and that's a drizzle donation. And I want to thank a bunch more raindrops: Nicholas Strohecker, Mine Silvestri, Cindy Urek, Stephen Theodore, I hope I'm saying your names right, because we are so grateful, Scott Finley, Andrea Glenn, and Joanne Gira. Thank you so much. We appreciate your faith in this program and in the ability for Red Rock to rebound. That's the hope for all of us.
Thank you, everyone, for your support, for your attention, for wanting to learn more about this, and for your great advice and opportunities, because, again, this is a long-term problem. We're really hoping to get that short-term solution for this winter right now with the help of Frank and his team at DRI, and working with you and the community and our legislators on a much longer-term solution. So you all are wonderful. Thank you again. We'll be sending the recording out of this, and I think that concludes our webinar.
Thank you.
Thanks, everybody.
Bye.
Bye-bye.